We are definitely not the first ones to build this type of setup. For example, there's a video tutorial by Stefan Sietzen who built this a few Houdini versions earlier. But as there have been some changes in the volume workflow since Houdini 17, I thought why not give this a go and build our version of this wind tunnel setup using Houdini's Pyro module. The first thing I want to create is our collider, the shape that we'll put into the wind tunnel. So let's drop down a geo, call this one collider, and dive in there. And this is a place where you create the geo you put into your wind tunnel. So in my case, let's just use the trusty old pig head, set this to easy. And in my case, let's just translate this a bit up, a bit backwards, and also let's scale this down to only 70%. Then let's rotate this around using a transform, rotate it around 180 degrees like this. So we end up with something like this here. And also subdivide it by one subdivision, so we'll increase the mesh's resolution like this. Let's leave it like this for now and create our smoke emitters, so the geometry from which our smoke is emitted. And smoke in Pyro is equal to density in our simulation, so let's again create geometry, call this one density underscore emitter, and dive in there too. And in here I want to drop down a sphere, set this one to polygon, give it a frequency of 8 to increase the mesh resolution, and dial back the uniform scale to something really, really small, in our case 0.02. And let's just move it up 0.3 units. Copy this, just dial back its position. Again, copy this, paste it, move it down a bit. And finally, this is my final sphere. Let's put down a merge and merge all this geometry into one stream, like this. Head up one level, and what I want to do with my collider, I want to translate it a bit like this, so it sits in front of those emitters here. And let's also maybe scale it back further, say to 0.5. So now we have it sitting in front of our emitters here. Also, what I need for this wind tunnel effect is some kind of quote-unquote fan to push air through my simulation and through my simulation volume. And for that, I'm going to create another emitter geo. Again, drop down a geo node, call it vel underscore emitter for velocity emitter, then dive in there. And in here, I'll just create a single box, and I'm going to scale it a bit. 1.6 by 1.6 by 0.6 units, and move it back along the z-axis a bit. Just like this for now. So let's dive back up. And now we have everything in place for our simulation. We have our velocity emitter, our fan, that pushes the smoke which we're going to emit from the density emitter here, from those spheres, through our simulation volume with our main geometry, our collider, colliding with it. So let's set up a whole simulation. And this is one of the rare cases where I actually like to resort to using the shelf tools. Let's start out with the PyroFX shelf here and start out with the billowy smoke, which we're going to emit from our density emitter here. Let's click on billowy smoke with the density emitter selected, and we'll create this basic dot net here. So we got a pyro object here. Let's first increase the division size to 0.02 like this. So we have individual voxels that are a bit bigger. And then for starters, I want to increase its size to 1.4 by 1.5 by say 6.6. And also move its center to 0, 0, and 3. So we can see now this is the volume which we're going to use to simulate our wind tunnel. I want to make sure to check we have closed boundaries, otherwise what is going to happen, our velocity flow will be modified so it points outwards on the boundaries, and we don't want that. We just want open boundaries along the minus and plus z-axis so we can push our velocity in this z direction through this volume. Next, we automatically created a source density volume source node. And we want to use that to only source the density and not temperature or velocity. This one is purely there to add density, that means smoke, in our simulation. Also, we have this resize container here, which is there to automatically resize our simulation volume to fit only to areas where we have active smoke in there, just to save us a bit of computational time. And I'm going to set the padding to 0.05. Down here, now this is looking at the density field in order to determine which parts of our simulation volume are quote-unquote interesting for our solver. However, what I want to do later, I want to use the velocity, which we haven't sourced yet, but which we'll do later. Also, let's check what we have in the max bounds tab here. And yeah, I want to clamp that to this maximum bounds, which I set up here in my Pyro object. Let's just finally check the Pyro solver itself. So in the simulation parameters, I want no buoyancy lift. So I don't want the smoke to rise by itself. Also, I dialed back the temperature diffusion a bit to 0.03 and leave the cooling rate as is. In the combustion tab, we make sure we haven't enabled combustion. And in the shape tab, all we want to have is a bit of dissipation, just a really, really tiny bit, 0.001. Let's just check the color, the relationships, and under the advanced tabs, I want to increase our substeps to be between 2 and 4 substeps. And I think we can leave everything else as is for now. So let's head up again. We can see we also added this Pyro import, which loads back the results of our Pyro simulation into our scene. So these two here belong together to our simulation, while these three here are the sources/colliders for our simulation. So let's organize them like this. And what I want to do next, I want to add my collider to my simulation. So I'll highlight my collider geometry node and go to collisions. And as this object isn't currently animated, I can go to static object, and that should have automatically added a few nodes in my pyrosim here. And yeah, it's these nodes we've added. So let's just lay out this properly. And let's just check in the collider object here. We are referencing our collider geometry here. And let's just, in the collisions tab, check we have our volume sample size for the collider set to the identical or a really similar value of our smoke sim, so 0.02. And that should be it for now for the collider object. So let's head back to our main geo and finally take care of this velocity emitter here. So when we head into the density emitter, we can see that Houdini created a few nodes for us, namely the create density, add noise, and rasterize. Let's just copy these 4 nodes, including the null here, and head to our velocity emitter here and append them below our box here, like this. However, I don't want any noise in my velocity, so I will delete that. And also, let's head back up and into our density emitter. I also want to delete the noise node here because I just want to emit solid uniform smoke. So back to my velocity. In the pyrosource node, I don't want to create density. I just want to create velocity. So let's just delete one attribute and set this one to velocity and set it to a default value of 0, 0, and 1. So it's blowing in Z direction here. Let's set this to a scale of 1. And we like this attribute to be created not only on the surface of our geometry here, but in our whole volume. So let's set this to volume scatter, which will take a while. But then we have a solid volume of points here, which is then used to create the velocity attribute. Next, let's just check the rasterize node. And in here, all we want to rasterize is our V, our velocity, and we can leave the rest set as is. And before we head back up, let's just call this one out_vel for velocity. And now we can finally head back into our pyrosim here. So this is the node which sources the density. So let's use this and modify it to also source the velocity by just copying and pasting it, calling it source velocity, and wiring it in the merge, like this. So let's select our subpath to our velocity emitter, which is the outvel. We want to have one operation, and we want to work on a vector field. Our source volume is called V, and we want to add this velocity to our vel field for our pyrosim. So operation is still set to add. And what I found after running a few simulations that a scale of 0.5 is resulting in the look of a simulation that I wanted. So let's scale that down a bit. And that should be it for now. So let's save this. Check real-time toggle, although we probably won't need that now. Keep our fingers crossed and simulate this. Let's stop this here. So that's already kind of working, but this volume is getting a bit too big. So maybe let's reset this, and in the resize container, let's try using the original density field instead of the velocity. That might have been a stupid idea. So let's just reference the density and increase the padding a bit to say 0.15, like this. Again, save this and resimulate. Okay, that is looking promising. However, to me this one here looks like an artifact of a volume that's not growing fast enough to keep up with the rapidly expanding and moving smoke. So again, let's reset this and set the padding to 0.25, like this. Again, saving and resimulating. So here we have it, the not really scientific proof that our pig head makes for a terrible aerodynamic shape. What I could dial in now is maybe expand this volume a bit on the top so we catch these turbulences here, and definitely in the pyro object decrease the division size to increase our overall simulation resolution, which of course will slow down our simulation as it needs more computational power. Alright, so that's the very basic wind tunnel setup using shelf tools this time, and modifying the results of those shelf tools a tiny bit to create a setup to our liking. If you like what we do and like to support us and maybe get access to more in-depth courses, head over to our Patreon. And for all of you guys who already support us, thanks so much. And a very special thank you goes out to Important Looking Pirates, Kyoko Sakane, Joseph Howerton, Nick, Chris Hebert, Rafika Nadol, Rob Bryant Jr., and Mohammed Al-Abri. Thanks so much, guys. Until next time, it's cheers and goodbye.